we are talking about all types of factoring, and we want to be able to use special product patterns to factor polynomials. So after we look for any common factors, the next thing we want to do is we want to count the terms in the polynomial. So if we have a binomial, we're thinking two terms. Or two numbers. If we have a binomial, there's a couple patterns that should pop into our head. So if we have the difference of perfect squares, so if you have x squared minus y squared, the way that we factor that is we use a conjugate pair. So we take the square root of x, and that gives us our first term in the binomial, and then we take, the square root of x squared, and then we take the square root of y squared, and that gives us our first term and second term of the binomial. And then the pattern repeats itself, so it has the same first term and the same second term. The only thing that changes is we have a minus sign for one of the binomials and an addition sign for the other binomial. And it doesn't matter if we put one or the other first, just as long as we have one subtraction and one addition. And that is our conjugate pair. The next thing we look at is sum of perfect cubes. So what do we notice here? We have x cubed plus y cubed. So that's sum, right? So sum, that's where we're talking about addition. And for up here, we're talking about difference of perfect squares. So we have the subtraction sign with two perfect squares. Here we have addition sign with perfect cubes. So the way that we get this is the number one thing we have to figure out is what is going to be x and what is going to be y, because then the pattern kind of fills out. Then we just have x squared, y squared, and then we have x times y there. So how do we make x cubed become x? Well, we take the cube root of x cubed. So we take this leading term out here, take the cube root of it, and that gives us our first term. And then how do we get the second term? We take the cube root of y cubed, and that gives us our second term. Then we take our first term, which is x, and we square it, and that gives us our first term of the trinomial. And then we take our second term and we square it, and that gives us our last term. And then we multiply the two terms together, and that gives us our middle term. Now we have so we got difference of perfect cubes. So it's the same. We got perfect cubes up here. We have perfect cubes here. This time we're talking about the difference. Up here we're talking about the sum. So that's the only thing that is different between those is the sign there. And it's basically the same idea. How do you get the first term of the binomial here? You take the cube root of x cubed, or the cube root of the first term. How do you get the y? You take the cube root of the last term. Then the same process. That becomes x squared, that becomes y squared, and the middle term is these two multiplied together. The pattern here might be a little bit different, so we wanted to see the addition minus addition minus addition addition. How do we remember what signs are which here? So the thing that you should notice is that there are two addition signs. So for both of these, sum of perfect cubes and difference of perfect cubes, there are two addition signs. or 2 addition signs, and 1 subtraction sign. Okay, so that's the first thing that you should remember. Whenever you're doing the sum of perfect cubes or difference of perfect cubes, 2 addition signs, 1 subtraction sign. The next thing you should notice is the last sign is always addition. So that one will never change. The last sign will always be addition. So you'll always finish with plus the second term squared plus the second term squared. And then the last thing to notice is the first sign always matches the sign in the original binomial. So here we have difference of perfect cubes, difference. So the first sign is subtraction. Here we have addition, sum, addition. First sign is addition. So 2 addition signs, 1, 2, 1 subtraction sign. The last sign is always addition. The first sign always matches the binomial. So minus, minus, plus, plus. And if we remember those things, we'll be able to make sure we put it together.